Good afternoon, buenas tardes, everyone. My name is Nigel Blanford, and welcome to the third in the 4 webinar series on smart homes. This is brought to you by the University of Salford and the European Regional Development Fund. So this smart homes webinar series, we do have a bias on energy here because that's, as you can see behind us, we are of the energy house, but a lot of the skills that you'll learn on this webinar are transferable, not just to energy, but across the smart homes arena. We're here mainly to assist Greater Manchester small and medium-sized enterprises. So those of you from outside of Greater Manchester, you've got those people to thank for your session, and having attended those sessions, those Greater Manchester SMEs will have be in the potential position to access the facilities of the University of Salford free of charge to do further research or to test their products at zero cost. Other companies are welcome to do so, but this will have to be on a commercial basis. You are all placed on mute, just so if you try to yabber away there and expect us to hear, we can't hear you. But there will be a question and answer session after each sort of presenter's session, and these are done via the text facility, which is up here. If you look in the top of your screen up here, there's a little box there with a question mark on. You type into that, we'll see that, and we will read that out for the presenter, or maybe myself or my colleague Yanis to answer. We've allowed generous time for the question and answer session, so that if it doesn't take that full time up, what we'll do, we'll just advance the whole sort of presentation series, and we will finish earlier than 3:30. There will be a comfort break around about halfway for 15 minutes, and we've set up some separately named meeting rooms which you can join in and meet your fellow participants in there. We will not come back in and tell you we're just about to start again, so it's up to you to sort of come out of that sort of comfort break room back into the webinar here. Please be patient. Touch wood, we haven't had any technical issues so far, but you know, this is still a new thing for us to do these webinar series. I don't need to tell you about fire precautions or turning your phones off or where the toilets are. So that's a plus point of doing it this way. And throughout the 4 sessions, you will gain something, or throughout the remaining 2 sessions, you will gain something. Even if they're pitched slightly higher than you might understand initially, there will be concepts, etc., rather than the details. So thank you for staying with us. Now, without further ado, we will move into the first session. The presenter, well, for the rest of the day really, is Matt Roderick. He's experienced in large-scale, high-profile, technology-led disruption of most recently energy and telecommunications industries. Now focused on enabling businesses to take advantage of the wider energy transformation in how we all consume, store and generate energy. Founder and CEO of Energy Data and Chief Technical Officer of Wonderwall Energy. Previously founded executive of the digitisation of GB's last analog industry, smart meter rollout, CTO of Vodafone's revolutionary and highly successful M-Pesa service, mobile banking, and technical director of Europe's first internet games service, Europe's first e-commerce service, and the world's first multi-currency e-commerce service. So without further ado, I present to you Mr. Matthew Roderick.
Thanks, Nigel. That was a mouthful, I bet, wasn't it? Yeah. Yeah. Hello, everyone. My name is Matthew Roderick. So over the last couple of years, we've been engaged quite heavily in the energy sector. So as Nigel mentioned, I was CTO for the smart meter rollout between 2013 and 2018, and really off the back of that work, we discovered, and I discovered more specifically, that it wasn't easy to access smart meter data. As we look through society today and the continuous journey towards carbon reduction, energy efficiency, reducing energy, consumption, increase in local generation and local storage, that entire energy transition to net zero has really started to scale up over the last 5 to 10 years, probably coming to a peak, and which we will continue over the coming years. What that means is data from domestic meters becomes far more important for the environment and far more important for the economics of those end users. You know, reducing your energy bill, reducing your carbon footprint, actually getting to understand how much energy you consume and when you consume it is fundamentally essential to, you know, reducing your bills and reducing your carbon footprint. So key activity is to try and unlock that data and understand that data and make decisions based on that data. That's sort of coupled with the transforming energy sector. We're all familiar with the slow demise of coal power stations. What will be next is the slow demise of centralized gas power station, and this general transition to a distributed, renewable, green set of energy sources, moving from a few hundred centralized power stations across any particular geography, the UK for example, to thousands, if not tens of thousands, if not millions of smaller distributed renewable energy sources. And how does that transformation happen? How does that work? Now, that combined with the electrification of the entire nation, we've already seen the continuous march to electric vehicles. We're seeing now the continuous march towards decarbonisation of heat. Effectively, through that process, we'll see at least a threefold demand increase in electricity. And how is that going to be serviced? Using predominantly or hopefully completely renewable resources and the challenges that brings. So in this morning's session, well, it's not quite morning still, but in the first session of this afternoon, I'll be talking you through energy data. It's pronounced energy, N3RGY. It's a platform to make it really easy, really straightforward, really simple for you to access the data that's locked away in your smart meter, whether it's in your domestic property or your business property. It's accessing that data and making use of that data to make decisions around your energy profile and your energy consumption, whether it's tariffs, whether it's solar generation, or whatever the journey you choose, which is best to reduce your energy footprint, reduce your energy bills, and reduce your carbon footprint ultimately. Just a little bit of background on the business. So this was founded almost 3 years ago. The business is a joint venture. Energy Data is a joint venture between Energy, which is my business and my business partner, and a company called Critical Software. Critical Software is quite an interesting business. They provide the development and operational services to Energy Data. They were founded back in the early 2000s, really to building services and software solutions for organizations like NASA, the European Space Agency. So the software product we have here is, dare I say, bulletproof. I'll regret that when we come to the demo a little bit further on, but a highly reliable, resilient service to access smart meter data. But why do we need this data? Why is it useful? So smart meter data, if you don't know, is effectively a digital version of your traditional electricity meter or gas meter. It records your energy consumption, and in the UK we've specifically chosen as a nation to record that energy consumption every 30 minutes. So throughout the day there are 48 readings on how you've consumed energy for each half an hour. Over the period of a year or 2 years, that increases to thousands upon thousands of data points for every single property to understand its consumption, whether it's across seasons, winter versus summer, across different weeks, across different weekdays, or actually across individual 30-minute segments throughout the day. You know, how much energy do you consume when you get up? How much energy does the house consume overnight? The fridge consume, the background appliances consume, and then obviously typically into the evening, how that energy profile increases at the highest peak moments in time, to cook your tea, to watch your TV, to play your Xbox, to do your washing, and so on and so forth. So that degree of data creates an enormous understanding of behaviours of the occupant, behaviours of the physical building. The thermal models of the building can be inferred from how much energy that building consumes through the days and the seasons, and much more. There are many organisations now looking to use this smart meter data for not just understanding consumption, to switch tariffs, to get better bills, reducing your bills, but also to produce all manner of interesting stuff, some of which we'll touch in the second session when I talk about Wonderwall. But this is a real core platform, that a platform of data that really provides great insight into understanding how homes work and businesses work, and how they are occupied and consume energy as a result. The energy industry has typically been difficult in exposing and sharing its data. Highly regulated, highly complex, highly traditional processes typically make it very difficult. What we've done with energy data is created a service which is truly modern, truly of the internet age, to make it really easy, really simple, but also secure and compliant with all the privacy policies that it enforces today, to ensure it's really easy for you to access your smart meter data, or the smart meter data you have permission for, and really easy for you to download that and use that for your whatever measures you choose to use, energy efficiency, bill changing, etc. And I'll give you some demos of that in a moment. Accessing data can be difficult, and I think we've all looked at ways of accessing different sources of data. It has traditionally been very difficult. What we've done as part of the energy data platform is to make it as easy as possible, building systems and services that allows you to really sign up as a cloud service. So you can sign up within a couple of minutes, a very simple process. The interfaces are extremely simple as well. You can integrate with days. The fastest customer went live in 36 hours. So if you're looking to use our service, you can have a go at beating that time frame, from sign up to launch within 36 hours, launch within weeks, which is more typical of our customers. And then there's 17 million meters in the UK alone that you can gain access to and start to grow the service you choose to provide, whether it's whether you're a registered social landlord or a private landlord, whether you're a company looking to monitor its energy use across your own properties, or whether you're a digital services provider in the energy sector looking to provide switching services or energy advice services to consumers or businesses. Really easy, really straightforward to access. So we uniquely provide access to 70 million meters, as I said on the previous slide. That's for people familiar with the smart meter rollout in the UK. We're currently 2/3 of the way through the time period, more or less. It's scheduled to complete in 2025, so not all properties, not all 27 million domestic and SME properties have a smart meter yet. We have access to all what's called the SMETS 2 meters and 7 million of the SMETS 1 meters, which are slowly being enrolled into the DCC, which is the network that connects all the smart meters together. We have a fully integrated consumer consent process, and I'll show you that shortly as a demonstration. Fully compliant with industry regulation. In fact, we hide all the industry regulation from you. You don't have to worry about the 10,000 pages of smart energy code which pertains to smart meters within the energy industry. We front on that, and we've built digital mechanisms to ensure compliance. Transparent, our pricing is on the website. I'll show you in the slide shortly as well, and it's a classic cloud platform. And finally, there's a free sandbox. So if you just want to experiment through the session today, you'll have access to the platform and smart meter data. But if you want to sign up for your own access to what's called our sandbox environment, which there's about 50 properties of anonymized data in there, then you can feel free to sign up to the service and start using it. Obviously, as we go forward, any questions, just pop into the chat window, and I can either pick them up as we go or capture them at the end. Feel free. And the final bullet point at the end of this slide around the architecture, it's a true internet age RESTful JSON Amazon Web Service, as more often it is these days. Service are really easy to integrate, really understandable for the vast majority of developers out there today. It's also a zero-touch service, and obviously over the past 12 months or so of the pandemic, dare I say, it's been extremely difficult to, if your businesses have been around accessing homes, accessing people, engaging, it's been extremely difficult with the restrictions we've had to have in place over the last 12 months. The Energy Day platform is a completely digital service. There is no physical access required to the property you wish to monitor and receive data from. There is no requirement for local internet access. There is no installation of devices over and above the smart meter, which has been rolled out already. And it's a very simple process to gather that consent from the consumer, again, digitally. No physical engagement, no visiting the property, no installing of devices in that property. There is, I must say, there is an alternative to using our platform. You can sign up directly to the DCC, who provides the smart meter network. It's not a simple process. There are 10,000 pages of regulation for you to review, and there is an extensive process to sign up, audit, authenticate, test, prove, review process to go through. It's not simple, it's not easy, but it's an option for you if you truly want to go down that. I highly recommend you don't, but I would say that, wouldn't I? The alternative is just sign up to our service and get access to the smart meter data. Simple as that. As I mentioned before, the system is designed to access multiple smart meter networks, and over the next few years we will be adding further networks, hopefully as we expand into Europe and beyond. But today we have 2 adapters, one to the DCC for all the SMETS 2 meters and the migrated SMETS 1 meters, and one other adapter to the secure meters SMETS 1 estate, which is about 17 million meters that are yet to migrate to the DCC. We have access to that, hence the 17 million total, 10 million through the DCC and 7 million directly through the secure meters SMETS 1 network. All of that is accessible through a single API. Meters are identical through the API. There's no complexity. There's no understanding which meter does what. It's a simple API that you can access any meter through that platform. The obligatory technical slide. If you're interested in the technical architecture, I'd be happy to step you through that in further detail. But simply put, it's based on Amazon Web Services using the serverless architecture platform, using things like DynamoDB and Lambdas and their schedulers and so on and so forth. So highly scalable, highly resilient, and highly secure. And as you can see in the top right-hand corner there, those are the connections to the various back-end systems, which we are planning to extend over time to other smart metering networks. So consumer sign up, I mentioned really easy, really straightforward to get consent for consumers. This is built into the platform. It's free as part of the subscription to the service, and it's really easy to sign up. It can be fully integrated within your onboarding process, your digital onboarding process, because everything's digital at the moment. And it's very familiar to consumers. It looks very similar to PayPal. And what do I mean by that? So if you go to a shopping site and you add things to your basket and you go through the checkout process, quite often there's a button that says pay with PayPal. You know, I did it yesterday when I bought some equipment from Screwfix, I think it was. Button pay with PayPal, it switches you to the PayPal site, you authenticate with PayPal, and then the money's transferred. Very simple, very familiar to consumers. We've taken that principle and applied it to consent for accessing data. So providing a service to consumers where you need to access their energy data, you can provide a service that your standard sign up procedure, whatever that looks like, and you can add a consent with energy button. Doesn't have to be branded this way. We don't have the restrictions PayPal have on their brand, but it's a very simple consent button that takes the consumer through your sign up journey into the consent process where we validate that consent. So we do all of that according to GDPR and to industry regulations and standards. And then at the end of that process, the control of those steps, those two pages is returned to you saying consent has been granted, complete the onboarding journey. You now have access to that consumer's energy data and legal, unambiguous consent for accessing that data. What that actually looks like is two mechanisms. One mechanism is the in-home display. So through the process, and I'll demonstrate this process shortly, but through the process, it prompts the user to type in the last 4 characters of the in-home display. These are some sample pictures of in-home displays and where the serial number is printed. Simply, the in-home display doesn't even have to be switched on. It just needs to be flipped over, last 4 characters typed in, and that's consent. That's authorization of consent. Some of our customers already have consent. They may be the landlord and access to data is built into the tenancy contract. They may already be the energy supplier of that property and wish to have a more reliable means of accessing smart meter data. Then for those scenarios, we have a trusted consent process where your existing consent is integrated into the and validated by the industry regulations, and that is then demonstrated to so there's no in-home display process to go through. Happy to talk you through that in any detail if anyone has any questions in that area. There's a couple of other things we've added to the service over and above the simple data access. We've created a consumer portal. This is quite key from a data privacy and consent perspective, and also from a GDPR perspective. If a consumer has provided consent for access to for you to access their data, then the consumer needs to be in control, full control of that consent, and visible, and that consent being visible. So we've provided a consumer portal so you don't have to, effectively. So the consumer can log into the consumer portal, see who has access to their data, withdraw consent for that data if they so wish, and also to download a copy of their own data. So complying with a significant part of the GDPR guidelines around control of consent, withdrawal of consent, access to the data that's stored with regards to that. So we've built that service, fully compliant service, so you don't have to worry about that. But obviously some customers wish to include other data, which they're free to do so. As all cloud commoditized software as a service platforms should and must have, we also have a customer portal. So this is a customer portal that we provide our customers access to the platform. It provides a dashboard of the services, the service usage, so how many consumers you have on board and consent for, online invoices, generation and regeneration of the API keys, and customizing the terms and conditions that we present to the consumer through the consent process. Warning messages around if you withdraw consent, then this service will stop working, and documentation around SDA and so on and so forth. So that's all in place. So a fully automated, fully commoditized, very easy to use self-service system to allow you to access smart meter data. Pricing, again, we've gone against what seems to be generally happening within the energy industry for the last 100 years. It feels very difficult to get pricing from some service providers within this sector. We've gone the complete opposite. We publicly publish our prices on our website. Here's an example. And very simple, very easy to understand on a price basis. It's an annual subscription for low volumes, and then a monthly per property price as consent starts to grow. The link below to have the full information if you so wish. From a technical side, this is really, so as I mentioned at the beginning of this session, I spent 2013 to 2018 building a committee designed government smart meter network for the nation, and making that work. There are challenges with that design, which will not be fixed now because of the nature of large-scale government projects. But what we've done here is, through the energy data platform, is to try to create a modern bent on that interface to really make it easy to access. So I would argue how it should be designed, but there's a lot of reasons why it works the way it does. But this is how it should be designed from an end user's perspective. So it's natively cloud, it's infinitely scalable, it's continuously available using cloud technologies. It's very simple, very logical, browsable API, which I hope I'll demonstrate shortly in the demo section of this presentation. It's highly responsive. Because we store the meter data in our central platform, so you can just come and collect it, and secure by design through our own efforts and through third-party audits as well. It's a business-to-business service, which I think I mentioned at the beginning, but it's a very simple API-based service. So this is an example of the API. I'll give you a demonstration in a second. It's keyed on the MPAN or MPRN. So I hope you're all familiar with that concept. That's the meter point number that is used within the energy industry. MPAN for electricity meters, which is a 13-digit code, the example you see on the screen, and MPRN for gas meters, which is a variable length code. Sometimes it's 9 digits, sometimes it's slightly shorter or longer. I've never quite understood why that's the case, but I think it's the way the gas meter network built up. Those MPXNs, as they're called, MPRNs or MPANs, are interchangeable in our platform. If you reference a property through an MPAN, you can access the gas meter. If you reference a property through a gas meter number, then you can access the electricity information. So they're completely interchangeable, just to make it easy for you guys to access the data. The first parameter is the meter type, gas, electricity. The next parameter is the data type, consumption, production, or tariff are the options in that area. The fourth parameter is the element. So with the vast majority of domestic properties, they have single phase meters, therefore there is only one element. Smart meters have just recently, the tail end of last year, started rolling out to 3-phase or polyphase properties, large households, businesses, etc. And therefore the that option will turn from 1 to 1, 2 or 3. You select a period, a start time and end time, and a granularity. Granularity options are half hourly or daily. So we do the addition of the 48 reads into 1 day as part of the process of the API in the platform, but we store the data in half hourly windows. And here's an example of the response. You'll see more of this in a second as I go through the demo. But this is the example of the data that comes back. As you can see on that left-hand side, that's tariff information that we show the standing charge separate to each price point of per half hour of the day. A smart meter can have a different price point for every single individual 30-minute segment of the day. Octopus Agile, as an example, has a completely variable tariff, whereas most domestic properties are on the flat rate 15-16 pence per kilowatt hour tariff. We show all of those through the platform. The middle list is the middle output is around the energy consumption. So we provide energy consumption in kilowatt hours down to 3 decimal places. That the same as it's stored within the smart meter. So for instance, the example you see there is from the hours of 9:30 to 10 a.m. 0.2129 kilowatt hours consumed in that half hourly period. And on the final point, this is a sort of designed as a business platform for businesses to access multiple endpoints. So there's a list of endpoints that you have access to there. Before we hit the live demo, is there any questions on what the content we've discussed so far in this session? Anything you'd like me to go over again? Okay. Let me share my browser window this time. As it jumps off the screen. So hopefully everyone can see that fine. Cool. So this is actually, sorry, I missed one slide out that I should have showed to talk through the workshop exercise. So the browser window you saw briefly there is at the following URL. This URL will be live for the next couple of weeks, so feel free to access and review at your own leisure over the next couple of days or weeks. The basic principle of this little exercise is around understanding how to use the energy data platform. It also gives quite an interesting sample. It gives 2 sample meters through this platform. These are live meters in real homes, i.e. my house, and another house I have permission for to use through this service. So you can download real data from real meters in from domestic properties. There's an example third-party application that uses the energy data service. So for those of you who just wish to explore the service and explore the data visually, then please use the third-party application. For those of you who are interested in the API and the formats of the data, then you can use the demonstration section within the web page I show you. And for those of you of a quite a technical persuasion, please feel free to use technology such as Postman, or to create your own interface into the API through this demonstration service to access the data directly. All routes are available to you. There's also what I should have added is there's also sample code in Python available at GitHub free to use and consume that allows you to use this data or to access this data. You just need the API key, which will be available on the next screen. You'll see shortly. Right, now let me switch across to the browser you saw briefly last time. So, live data demonstration specifically built for this session today. The demo in the first section, in the workshop information section, that's the demo API key. So this is the key that you need to use to access the smart meter data. So if you're technical and you want to access the API directly, then please use this key. If you're less technical, feel free to use some of the other services. But basically the two MPANs we're using, the 2 meters and 2 properties we're using is MPAN 1, which I believe is a SMETS 2 meter, just downstairs from me in my home here, and MPAN 2 is a SMETS 1. I might have this the wrong way around, by the way, but one of them is a SMETS 2 meter, one of them is a SMETS 1 meter. One has about 16 months of data behind it, the other one has about 5 months of data, so feel free to use it. As we scroll down a little bit, this is the simple third-party service, so this allows you to just click through and build. This is built by a prosumer, so I call it, a chap called Guy Lipman, and it provides a really interesting view on consumption, and I'll click into that in a second. From a demonstration perspective, to access the raw data itself, you can use this section, the demonstration section. Please place and set the API key into this window and click the set button before clicking on this, because that authenticates to the API. There's the consent process, which I'll show you shortly, and there's an inventory system, which we may not touch upon today, but let's see how it goes. So, for a sort of simple browse of the data in a visual means, we have the third-party service provided by Guy. So if I just click on that, there you go, I didn't. Okay, this one works. So you just click on the link. Meter 1 looks like there's an issue at the moment, so meter 2 seems to be working. Click on the link. Firstly, the service needs to load your electricity data or gas data into the browser, because this is all processed within the browser, and then it allows you to start clicking through some of the links on the left-hand side. So, for instance, as you can see here, I have a period from, this is obviously the SMETS 2 meter, so I have a period from November last year till this morning, of energy consumption. There are no gaps in the data, which is good news. There's sometimes gaps which we go back and fill in automatically as part of the service. So there's about 5 months of data in there to look at. So we can click on the consumption tab. As you can see, this has been my consumption over the last 5 months, relatively low in November, December, but then peaking up in January, February, and the beginning of March. You can click down into individual months. So let's look at January, and it shows a daily view of my kilowatt hour consumption on an every day. You can typically see when I'm in and consuming energy, and when I'm probably in less and less energy is consumed. And if we can pick up on, let's look at that 11th figure, just as a matter of interest, the lowest volume. You can see over the period of time then very low, so no particular peaks at no time. It looks like I was probably out that day, as at no point in time a half-hourly period consumed more than 0.1 of a kilowatt hour in a half-hour window. If I go back to the monthly figure and say, well, January 25th was a high consumption day, go back into that area. As you can see, I probably used the oven quite extensively in the late evening, 8 o'clock, and probably some other high energy use in appliances. But again, As very typical with energy consumption, very low consumption over the evening. You can see what time I get up in the morning with the kettle coming on and toasters and grills, and then relatively low consumption through the day with an early evening peak and then a later peak in the evening. There's other features of this service. You can other features of the service in terms of understanding cost profiles, bill calculators, tariff comparisons. So for instance, if I switch to the northwestern England, and feel free, guys, feel free to go to the web page, homebrew.energy.com/Salford, and experiment with this yourself and ask questions as we go. Do a tariff comparison. So for instance, for the month of January, my tariff, I would have paid less on the Go tariff than I would in an Agile or Silver tariff, and you know, my current tariff is somewhere in between. So it gives a really nice view on whether alternative time of use tariffs would be beneficial to me or not. And and in my particular circumstance, my particular consumption pattern, it's pretty good, the tariff I'm on at the moment, which is nice to know. But other consumption pattern might mean time of use tariffs is far more advantageous. Generating a report for the last couple of months on my energy consumption, which is blue, versus the average Ofgem profile versus time of use. I think this is particularly an octopus tariff price point. So as you can see here, I typically use more energy throughout the morning than the average customer profile as published by Ofgem, slightly less energy during the day, and then slightly more energy into the evening. And as you can see, with my profile compared to a typical Agile tariff, for example, we see I use a lot of energy in the peak cost period, and therefore, unless I do something about that energy usage, shift my consumption patterns, change my behavior, or maybe implement energy storage such as batteries, then as I mentioned, as I showed through the tariff comparison, it's not a great deal for me at the moment, but that will change based on changing behaviors and changing energy assets. So that's a quick run through of Guy's tool. Really extensive, really interesting tool. As I said, Guy is a prosumer who's developed this tool free of charge that you can access energy profile data through that. So if I just skip back to that page, homebrew.energy.com/Salford. Going down, so that shows an example of the services we provide, or we provide data to, and there's plenty of other services on the market, either in the process of launching or already live. But the data itself is available through our API. So this next couple of screens you'll see is what the raw API looks like that provides data to the services such as the one Guy produced. So if I click on this data, so this is the API call, and as you can see, as shown in the previous in the slide a couple of slides ago, it's keyed on the meter point number, and we have the option of gas or electricity data. You can, with this particular rendition of the API through a web browser, we've made the links clickable. So if you click on that, you can see the link change to electricity. If you click on consumption, you'll see the link change to consumption, and click on element 1, and it shows the data for the default is yesterday. So as if you remember back on the example slide, there's a start and an end time. If you do not give it a start or end time, it shows yesterday's consumption. Very simple. What I've also provided through this service is a link to daily and half-hourly reads for longer period of time. And what the service also does is, and this was part of the requirement around having a copy of Excel on your system. If you're comfortable with Excel, please feel free to click on these links, download the comma-separated values that I'll show you in a second, and start mapping and producing analyses of this data in your spreadsheet in Excel. There's two links for each meter. One link provides a daily view of data, so this shows the months of January and February. As you can see, start time, end time, output CSV granularity equals day. And this shows every day of the month of January and February in terms of total daily usage. We also provide a half-hourly link, which shows, again, in CSV format, for every 30-minute segment of the first week of March. So feel free to click on these links, download this data, load it into Excel, and analyze to your heart's consent. The consent process is something we've talked about. What I'll do here is to show you how simple the consent process is and how simple it is to integrate. Again, on GitHub, if you search for energy, you'll see this sample code that sits behind this process, and you can feel free to use that and integrate that into your own software development and work. But this shows a simple demo. So if I pass the MPAN into the consent process, so imagine the grey pages you'll see over the next couple of steps are sort of behind the scenes view. What the consumer will see is their onboarding process through your system, and then the handover to the sort of white gold pages, which is the consent process reel that will be presented to the consumer. So that is meter 1, which is, I'll cheat and just copy and paste. These are not my real IHG maps, by the way. I've modified them for the purpose of the demo. So if we start the consent process, the first step of the consent process is for the system, your system, to get a session ID. So this wouldn't be visible to the consumer, but it's starting the setting up the consent process. So this next page will be visible to the consumer. It presents the terms and conditions. These are your terms and conditions that you wish to present to the consumer, combined with the energy terms and conditions. As you can see, so that would be changed to your business name, and your terms and conditions would be placed inside there. As a consumer, I say, yes, I agree to those terms and conditions. The system then looks up the MPAN, looks up the smart meter, finds the serial number of the in-home display, and then prompts the consumer to effectively fetch their physical in-home display. Here's one I prepared earlier. This particular one requires you to take the back off it, look at the bottom, read the last 4 digits, type that into the system, hit submit, and I typed the wrong one in, obviously. Okay. Let's try that one more time, but it normally works quite well. This is for 8735, so it should be CDEE. Did I confuse? Okay, something's gone wrong. Classic trick of live demos. This has probably happened because we manually modified that serial number, the IHD MAC, in order for this demo. So I'm not giving my real IHD MAC away through the demo. And what it looks like is the system's detected that and refreshed it with the actual MAC address. So we have a slight problem there. So I'll take a look at that. But please feel free to log into the system, to use it, and to try the facilities we have available that I've shown. Any questions? So please feel free to experiment with that interface, experiment with the third-party system, download the metadata, use it in Excel, or use it in whatever your preferred application is. Any questions over the next half an hour or so, well, up until the next session, basically, please let us know in the chat window, in the Q&A window, and we'll be able to address those and talk it through.
I've got a question for you, Matt.
Yeah.
So as a person with a SMEX1 smart meter, obviously I'd like to enroll and get the metadata out there. Unfortunately, when I was supplied with a SMEX1 smart meter, I was given the option, do you want an in-home display or do you want an app on your phone? Now, I went for the app on my phone. So what do I do in that situation?
So there's two options so unfortunately the way we've built the platform is it's all around using the in-home display to authenticate, and in terms of accessing your own personal data, that's the digital process we chose. The alternative would be for us to build a process that requires you to send us a copy of your driving license and your utility bill and various other documentary evidence. It's a paper process, and we've chosen to build a digital process. So you've got two options. You can either sign up to a service that uses our trusted consent mechanism, because there's a couple of organizations using that at the moment. One uses credit card numbers to validate, others uses a physical delivery of one-time codes in effect, and various other mechanisms depending on occupancy and tenancy agreements. The alternative is just ask your supplier for an in-home display. They can pair it remotely, they can send it to you through the post. So as soon as it comes through the door, typically what we've seen is the display takes a week or so to arrive. There's no worry about losing data from the smart meter. Smart meters store 13 months of data themselves. So as soon as you get that through the post, you don't even have to switch it on. Just flip it over, type the number into the process, and we'll collect the data for you.
Thank you. We've got a one question has come in there. I don't know whether you can see that in the Q&A box. We've published it there.
It just didn't refresh. I'm just refreshing. No, oh, published. Here we go. Hi Raj. How can I call the API directly from the browser? Saying unauthorized. So you cannot access the API directly from a browser. The set of grey screens I showed, and let me just reshare those screens. The set of grey screens I showed you through this browser is effectively a front to the API, a browser to make the service browsable. So if I click on back into this, so that API call is technically this screen is a CGI script that makes a recall to that API. If you want to call it directly, you can't use a browser. You'll need to use something like Postman, and you'll need to use the the authorization header within the HTTP header. So it would be authorization : that string. So in Postman, if you call, let's just click around to make things confusing. If you call this endpoint in Postman, before you call it, set a header value of authorization spelt with a Z, unfortunately, because it's an American standard. Authorization : with this as the value, and you'll be able to make the API call directly to the API. Let me jump back to that holding slide so you can see the links, etc.
So Raj has followed up and said, could I use WeGet, WGIT?
Yeah, if my memory serves me correct, is it a -H, capital H to this is to set the header information. So let me just do a quick Google on the man page, but I seem to remember it's a -H to set the header. So so a quick look. There's always 3 million options in terms of it's minus header equals header line. So it's effectively you put --- header equals open quotes authorization with a Z : space and the API key close quotes, and then the https://api.data.energy.com, and that will give you access to via wget. Never used wget myself, but that should do the trick. There's no other. The only authentication string is that that code. We don't rely on any other HTTP headers or any other cookies or anything like that through the service. I'm just going to check because the meter 1 doesn't work through the third party through Guy Littman's application, but meter 2 does work. So please feel free to use meter 2. I'm going to just check why meter 1 isn't working to see if it's down to 13. Yeah, as expected, the temporary in-home display serial number that I put in for meter 1 has been refreshed with the actual serial number. So unfortunately, the meter 1's offline at the moment for Guy's demo, but you can still access that data through the demonstration section of the pages below. That part of the service does not rely upon the IHD serial number.
Hi, Matt. I would like to ask you a question. Your presentation was extremely useful and interesting. I would like to ask you in relation to a social housing scenario. What would be the typical, from your experience, what would be the typical coverage? What percentage will be smart meters?
Really interesting point. So we've done a couple of analyses for a number of social landlords and social housing providers. At the moment, the average smart meter penetration is around about the 30% mark. What we've found through our analysis is quite varied. So the lowest penetration in social housing of smart meters for a particular supplier, obviously I won't name that social housing provider, is 25% penetration. So 25% of their estate has smart meters. We did another one which hit about 33%. Obviously this is increasing on a day-by-day basis. And a third one who have been very active in encouraging their tenants to take up the smart meter and to actively manage their energy bills for obvious reasons around fuel poverty and energy costs. They hit about the 64% mark. So 64% of their estate was smart. As we roll in towards 2025, that number increases, and the plan from government and Ofgem is that should hit 100% penetration or very close to it by 2025. So yeah, a really sizable installation base to begin with, at least a quarter in our experience, sometimes significantly higher.
Matt, another question. Could you please say a few more things about the GDPR and the data privacy aspect of the platform?
No, absolutely. So hopefully the majority of us are familiar with GDPR, General Data Privacy Regulation, if my memory serves me correct. So this is regulation that came into place, I think it was around 2015 or thereabouts, which requires unambiguous, informed, uncoerced consent, without coercion, consent from the data owner to any business or any individual or business wishing to use that data, with a number of requirements around being clear in the informing of what data is going to be collected, what data will be stored, how long that data will be stored for, what it will be used for, will it be shared with any other person, and so on and so forth. So there's quite strong European regulation around personal data now. So that had, through industry regulation, sorry if I step back a little bit, general GDPR regulation requires businesses to have all of that in place. It also requires businesses, it will, through the Information Commissioner's Office, it will fine businesses for breaching those GDPR policies, and the fines can be eye-watering, as I think British Airways found out a couple of years ago. Tens of millions of pounds of fines, significant proportion of their annual turnover, which is how fines are defined. Through the Energy Data Service, we take privacy extremely seriously. We take not just the general GDPR regulation, but the industry regulation that sits above and beyond GDPR. So as part of our GDPR compliance to help our customers and our own compliance with industry regulation and general GDPR, we've built the consent process and the consumer management system. For smart meter data, through industry regulation, it goes one step further, whereas general GDPR requires you to have a process in place and to follow it. And if you're caught, then you get a big fine. If you're caught not following that process, you get a big fine. Within the energy industry, they wish to audit that process before you get access to smart meter data. Our processes have been audited already, they've been approved, they're already in place, so that's something you don't have to worry about. But generally, prior to access, process needs to be audited and confirmed within smart meter regulations, and then consent is granted to access. But that's something you don't need to worry about with the energy data platform, because we've tick those boxes and continue to tick those boxes in our annual privacy and security audits. Any further? I see Raj has been working on some more wget, so if anyone else wishes to use the wget command, then there's an example. I'm not. Is the Q&A visible to everybody? I think it is, isn't it? Excellent. So you can see a very simple command line activity to download that data. Don't forget the parameters at the end: start time, start equals, end equals, output equals ZSV if you don't want to deal with JSON data, and granularity equals day or half hour. To tweak the way the data is presented back.
Got a question for you, Matt, using your experience of working in this field for quite a while. You briefly chatted about three-phase or polyphase meters. How quick do you think is both the industry and the DCC pushing for this polyphase smart meters?
So the first couple of, I think it was September last year, I know the manufacturer and I know the installer that installed the very first SMETS 2 polyphase meter. So that was installed August, September last year. There's been a few out to date. What's happened through the BAYS innovation projects, there's now a lot of work and some funding being delivered to organizations wishing to consume smart meter data from these commercial installations, because typically polyphase is for commercial installation. One good example is an organization called Energy Sparks, who are working with schools across the country to get them to get smart meters installed, typically polyphase, and B, to report their energy usage. And I believe through that process, schools' energy consumption on a half-hourly basis will become public domain data, which starts to get really interested in terms of those schools consuming energy efficiency advice or infrastructure or services. If they publish their smart meter data publicly, then anyone can analyze that, and anyone can really offer effective services to reduce their bills, reduce their carbon footprint, and to create a greener, more efficient school. But it's just starting to kick off now. As I say, there's a small number of SMETS 1 polyphase meters out there. SMETS 2 has just started installing last year, so I expect over the next couple of quarters that really to ramp up with schools and other businesses in the loosest possible sense, taking on board energy advice and trying to take control of their energy use.
Thank you. I think there's another question coming from Raj.
If you move energy providers, is the data. So sure, this is a really interesting. So if you move energy provider, is the data available over the transition from one provider to the other? So this process in the energy industry is called change the supplier, changing from EDF to Octopus to OVO to E.ON to, I hope I haven't missed any of to Good Energy to Shell and so on and so forth. So switching suppliers. Typically, you switch suppliers in order to get a better deal. Simple as that, and reduce your energy bill. The way smart meters work are for energy suppliers. And I'll get a little bit technical here, but not too technical. Energy suppliers install their cryptographic keys into the meter, and they do not have access to the data within the meter until their keys are installed. So, for instance, I switched from my old energy supplier to my new energy supplier. I think the switch date was Christmas Day, to be honest. And at which point my new supplier had access to my energy consumption information from Christmas Day onwards, but not before. And my own supplier had access to the energy data after Christmas Day, but not after. So that's the way smart meters work. The service we provide is not based on the supplier model. We're a third-party accessing smart meter data. So we are not affected by switching suppliers. So we can provide data before that switch, after that switch, and during that switch without any hiccups, without any delay, without any change. So smooth every day. We pull that data down, you can get access to it. You know, whether the day before was supplier A, the day after is supplier B, or the day after that is supplier D.
That's great. Thanks for answering that. Have you got any more of the presentation to go, Matt, or are we ready to move on to a comfort break now, if there's no more questions?
So that pretty much covers it. Really giving you guys time to experiment with the service, whether it be the third-party service by Guy, so you can just point and click and look into the query the data, or to actually download the data and take a look through the direct API, as Roger's been doing.
That's great. So what we'll do now, we'll move into the comfort break. We'll come back at 2 o'clock. So that gives us, we're about 15 minutes ahead of time here. So yeah, we will see you all back here at 2 o'clock. And there are the networking rooms there in the comfort break rooms. They're obviously typed onto the screen there, but you have had the email with the link on there as well. Thank you very much. See you in 15 minutes. Hello and welcome back. We have again got Matt Roderick speaking. So we've just heard previously about the energy data and how you use it, but how do you actually then apply that in the home? How do you make those savings? So I would usually go through the introduction of the speaker, but it's still Matt's. So without further ado, we will switch straight over to Matt Roderick for his second session. Thank you. Just waiting a little bit there for Matt to come back online. So this is probably where I need to sing a little song or something like that. We'll go on hold for a little bit longer now, and looks like we've got a slight technical hitch, but stay with us, please.
I'm here.
No. Okay, everybody, we are back and straight over to Matt over in South Manchester, I believe, still.
No, North Manchester now.
You're North Manchester now, okay.
Get around a bit. So let me just share my screen again, and we'll be off. Cool. Hopefully you guys can see this. Cool. Okay, so the second session today is Wonderwall. Yes, you've got me again, because I'm involved with both businesses, Energy from a smart meter collection perspective, and Wonderwall from a net zero domestic property perspective. And I'll explain more about that as we go through this. But Wonderwall was founded about, what was it, 8 years ago, something like that. 6 or 8 years ago, really focused on home automation, so digital intelligence within the home, really to understand how a home works, how it's occupied, how occupants use the home, which rooms they occupy, the temperature of the rooms, the humidity of the rooms, and movement throughout the home, to really understand a clear picture of how homes are used, because we all use our homes slightly differently, but very similarly that we found through the data that we collect through Wonderwall, and then to use that data to do something important. Now, similar theme as we talked about this morning, it's all about energy costs, it's all about energy carbon footprints, it's all about energy reduction, and ultimately getting to the point where we can reduce our energy costs massively and reduce our carbon footprint massively to serve the environment and to serve the natural world. So, as I mentioned, it's all about climate change. Why? What is Wonderwall doing, and how are we doing it to combat predominantly climate change? But what comes along with that is things like fuel poverty, things like energy costs. I think, not sure everyone's aware of this, but if you look at the stats on the average energy bill over the last 15 years, the tail end of the 2000s and noughts, or 2005, 2008, that sort of timeline, the average energy bill was around £400 a year, £400 to £500 a year. What we're seeing today is the average energy bill is £1,300 a year. You know, that's driving more and more of our society into fuel poverty. The price and cost of energy is continually going up. Yes, some of that cost is related to the decarbonisation agenda, but some of that cost is just related to the price of the system and the energy just generally going up over time. And that isn't forecast to change anytime soon. With the investment within the energy system, I think Ofgem announced a £30 billion investment in the energy networks. Energy generators are investing tens, if not hundreds of billions of pounds in new generation facilities, renewable generation facilities. That all ends up on the consumer's bill, on your bill, on my bill, on Nigel's bill, on everyone's bill. Someone has to pay. So your energy bill is not going to go down unless you do something about it. And that's where Wonderwall comes in. Our mission is basically to change the way, change our relationship with energy, and change the way we live and how we use energy. Our vision is ultimately to make every single home, not just those super efficient, passive house standard homes, to be ultra energy efficient, but every single home in the country, all 26 million in the UK, plus the hundreds of millions across the rest of the world, to be ultra energy efficient and to achieve net zero, to power a brighter future, as we say there. The Wonderwall approach is slightly different, well, it's significantly different to many of the traditional approaches in the market. At the heart of the system is a light switch, and I've got one here. Light switch fits in a standard light switch single gang box. Standard wiring, everything physically is standard about this light switch, and I'm not holding it upside down, which is even better. Part of the system is a light switch. This light switch has 13 different sensors. It's not just a light switch to switch the lights on and off. It has an array of sensors that covers temperature, humidity, power consumption of the light and circuit, motion within the room, the luminosity of lighting the room as the light switch is on and the window open, is the sun shining through, and sound and microphone sensors as well. If you imagine the average domestic property has somewhere between 10, 13, maybe more light switches in the home, deploying 13 light switches with 13 different sensors in each effectively creates a sensory network within the home with 150, 180, 200 plus sensors. Understand exactly how that home is used, how it warms up, how it cools down, which rooms are occupied, when those rooms are occupied, the humidity levels, the luminosity levels, is this a light bright room, is it got a dark room, and so on and so forth. You're truly understanding not just the property's behaviour, but how that property is used by the current occupants. You know, incredible amount of data. As from a volume perspective, we collect around 20,000 data points a day from the average home, and those data points are purely used to make that home more efficient and more effective and more livable. So we start from that digital intelligence with Wonderwall and the light switches in the heart. So there's no sensors, little plastic boxes with their own little batteries that are dotted around the home. This is simply swap out your existing light switch, pop in a Wonderwall light switch, and then you start to build up that volume of data. I said some of this already. So understanding from those 20,000 data points a day and combining them with other data sources. So I mentioned in the earlier session around the smart meter and the tariff information, the consumption information that's gathered. Wonderwall also uses that information to understand how much energy that home is using, how much energy is that home generated through solar generation, which is the most popular by far domestic generation capability, battery performance, water heating, energy tariffs, smart meter information, import, export, wholesale tracking tariffs such as Wonderwall. The energy market is becoming much more complex. It's not just a simple matter of saying, I'll find my energy supply at 15 pence, 14 pence a kilowatt hour, and that's what I'll use. There's far more effective ways and far more complex ways to reduce your energy consumption, to reduce your energy bills. So through this extensive collection of data, we make decisions for the house and for the residents to optimize their energy use, to reduce their energy system, to predict the behavior of the occupant and the behavior of the home based on external temperature, based on the day of the week, the time of the day, the month of the year, so to speak, to gather all this together. There are 4 primary drivers to Wonderwall's AI platform. The most fundamental driver is to minimize energy consumption. As we have sensors in every room and we have control over the heating system and hot water system, it's about avoiding using heat. So our approach with Wonderwall is quite significantly different to many other approaches within the market. Most approaches in the market are highly susceptible to the second law of thermodynamics, i.e. energy will escape regardless of what you do. So regardless of how super insulated and how many tens of thousands of pounds you spend on creating the most perfectly insulated home, and you can test those insulation products at Energy House at Salford. But regardless of how much you spend, there is no such thing as a perfectly insulated home, and therefore energy will leak out over a period of time. The better insulation, the longer it takes, but ultimately it will escape. So the Wonderwall approach starts with not pushing that energy into the home in the first place. So if there are rooms unoccupied, don't heat them. If the homes are unoccupied, don't heat them. If water is not being used, for instance, you have a 200-litre tank of hot water, but you only use 30 litres a day, why heat 200 litres every day? Why not just heat 30 litres? This is what the focus of the Wonderwall solution is, to reduce energy consumption, to minimise that consumption in the first place. So if you don't use it, it can't be lost. The second core tenet of our AI platform is to maximise solar generation. So through a Wonderwall equipment deployed within a home, we maximise the solar panel deployment and maximise the energy that comes from that solar generation. So using that energy as it's produced throughout the day while the sun is shining, and storing any excess energy in the battery for use to the typical occasions of typical times of day where that energy is consumed, which is typically sort of the 5-6 p.m. through till 9-10 p.m. in the evening is the average domestic property's highest consumption period. We also minimise grid costs as well. So using time of use tariffs, using wholesale tracking tariffs, we minimise that cost. So for an example, on a sunny day, we'll we will predict that sunny day through weather forecast. We will predict the amount of solar energy generated by that individual property. We will predict the consumption patterns for that property. And if it's a particularly sunny day, we will not charge the battery overnight off the cheapest grid electricity, because it's typically overnight. And we will use the solar panels to both power the home and charge the battery, and then use that stored solar energy into the evening, creating a grid cost of effectively zero. If there's an excess of solar energy, then that energy would be exported to the grid, which means grid cost for that particular day would be negative. Not every day in Manchester is sunny, as we all are very familiar with. So some days, such as today, is quite cloudy, not great, bit of rain around. Solar energy will be a lot lower than the summer months. In that scenario, again, the Wonderwall AI system will predict the energy generation the day before based on weather forecast. It will predict the domestic load based on historic trends for that day, that week, that month, and make a decision whether to import energy from the grid, i.e. charge the battery up. Again, typically overnight when the prices are lowest, take the charge from the grid. That could be, in recent months, the price per kilowatt hour has been 8 to 10 pence, so almost half the prices of the flat rate tariffs. Before that, through the summer months and the autumn months particularly, sometimes that price goes down to 2 pence or 3 pence, or even negative. You know, being paid to take energy off the grid, because that's the nature of energy supply and demand in periods where there's very high supply and very low demand. The price of energy can go negative, so Wonderwall will take advantage of those low prices or even those negative prices. And ultimately, through that process of minimizing energy consumption, maximizing use of solar, minimizing the cost of grid, the energy costs are a very strong proxy to the carbon footprint of energy. And going forward, with some of the government consultations and announcements that we've seen in recent months, it's a very clear picture that, you know, the potential for carbon tax on gas-generated electricity, the potential for carbon tax around coal-generated electricity, although luckily that's very little energy is generated from coal today. But the price of energy is now directly comparable to the carbon content of energy. The less you pay for a kilowatt hour, typically the less carbon content that kilowatt hour will have, to the ultimate point where if you're taking those kilowatt hours from the solar generation on your roof, there'll be zero carbon content and the price will be free. So how does it work in a slightly more, this is quite a complex slide, but I've discussed the key principles. Effectively, what we do is analyze your consumption profile and make decisions in real time on where to get the energy from. So the grey line you see is a typical economy 10 tariff, where there's 10 hours per day of low cost energy. The yellow line, the goldy yellow line, is a typical economy 7 tariff, where there's 7 hours, typically overnight, of low cost energy. There's an EV tariff, which is simply, you know, simple principle applies, low cost overnight figure, reasonable price through the day, and then there's the wholesale tracking tariff, which is the purple line. So based on the tariff you're using, and through Wonderwall we can recommend the right tariff for you, but through the tariff you're using, the system will be optimized based on your consumption profile, the amount of solar energy generated, and the cost of energy. And obviously, when that cost of energy goes up, as you can see through those grey areas into the red zone, we use the battery to power the home. in the red zone. In the grey zone, in the middle, we'll typically use the grid or battery depending on the consumption profile of the home. And in the cheap zone, that wonderful green colour, that will be the low cost zone. And the little bubble you see in the middle is sort of typical solar generation to say, actually, for that period, energy is cheap, so please use that as a priority. And the text on the left-hand side basically describes what I talked about in the previous slide around priorities energy use, minimizing use, and prioritizing low-cost energy as a result. As a result of all this, we've typically seen so I'll step that into a second. Let me talk through each component of the system. So Wonderwall has 3 core product offerings, let's call it. If we start with the home automation, we start with this data collection mechanism to really understand the capability and the usage of the property, the dynamics of that property, how fast it warms up and cools down, how individual rooms warm up and cool down, and the speed of which to understand their thermal behaviour and the occupant's behaviour within that thermal envelope. That's the real driver, that's the heart, that's the intelligence of the system. The light switches and the home automation solution does a lot more than collect data. It obviously switches the lights on and off. It has an Alexa, excuse me, it has one built into every light switch, so you can use voice control to control the Wonderwall system. You can control the system through the standard Amazon Alexa applications as well and services, so it's fully integrated to that system. It has a built-in burglar alarm. Through the motion sensors, there's a burglar alarm built into it. It has built-in music ability, so you can play internet radio, you can connect it to Bluetooth speakers, Sonos being a perfect example of that. So the Wonderwall system is integrated with the Sonos home speaker system, so you can ask your light switch to play music from your speakers, your lounge speakers, any internet radio system or Spotify or any other platform you choose to use. That's all part of the Wonderwall home automation solution. So very advanced, very capable, voice controlled system. I did hear of a we mentioned social housing in the previous presentation, and interestingly enough, Wonderwall has been deployed into a number of those environments. And what we found, one particular example, which was a very sweet example, where one elderly person living alone actually used the light switch to play games. I think I'm trying to remember what game he was playing, but very simple games as a means of sort of staying in communication, having a conversation with something, Alexa in this instance, and to play a crossword puzzle, I think it was, or Sudoku, or a similar sort of game that worked well in voice. I must double check what that game was. But really sweet and really, real issues in today's society while we're all in our own homes more often than not these days. But that's solution one: home automation, data collection, and voice control and those services. The second element of the Wonderwall solution is around an intelligent gas-free heating service. We use an intelligent hot water tank, and as I mentioned before, why do we heat 200 litres of water when only 30 litres of hot water is used? This solves that problem. The Wonderwall tank has the ability to learn consumption behaviour of hot water and only heat enough hot water to consume. So we're not daily heating 200 litres, we daily heat in maybe 30 litres, maybe 40 litres. Maybe on the weekends we use 90 litres, so we'll heat that for the weekend. So that's our hot water. Direct electric, again, taking electricity either from the solar panels, from the battery storage or from the grid, and at those moments of low cost energy. The space heating solution, our preference is infrared panels and or underfloor, direct electric underfloor heating. Exactly the same principle applies in terms of uses of energy. With those heating sources, we can individually control and heat each room on a separate schedule, which is learned from the occupancy behavior of the occupant. So for instance, if you come home at 6 p.m. each day, obviously, you know, the world is a little different at the moment, but if you come home at 6 p.m. each day and you spend the next 4 hours in the living room watching TV, then make a stack in the kitchen with a late night heater, and then go off to bed, we will only heat those spaces that you use. And we'll learn that behavior and preheat those spaces as you use them. So I'm very much a proactive activity of space heating. Another perfect example is the spare room. If you have a spare room in your home, more likely than not, that radiator valve is left open and that room is heated regardless of whether anybody ever opens the spare room door or not. Why do we expend energy heating a room which maybe gets used to put the towels away once a week? Why spend that money? Why burn that carbon to heat that room, where the system can simply learn the room is never occupied and never heat that room? I mentioned, if you remember back in the as I talked through the capability of the sensors, there is a humidity sensor within the light switch. So obviously one of the challenges, especially at winter time, is humidity build-up in an individual room, and if you're not applying heat to that room, then you could potentially have damp issues. That's built into the system. If humidity builds up within any room, the system will automatically burn that humidity off by applying heat. But that will be a lot less than heating that room 7 hours a day, 7 days a week. The intelligent gas-free sort of solution element is also designed for the shortly to be implemented new home requirements where there's no fossil fuel, i.e. no gas, allowed to be used in new build homes. The full expectation of the industry and markets is that's 2025, by the way. The full expectation is that we will start to look at removing gas from existing homes shortly afterwards, because we have to. You know, the vast majority, I think 75% of UK properties today use gas central heating, mainland gas central heating, combi boilers, and that's an enormous carbon footprint that needs to be addressed before we can achieve net zero as a nation. So combi boilers, gas boilers will start to be removed. Many social landlords and social housing providers have already started this journey, and it will have to be accelerated over the next 5, 10, 15, 20 years to reduce our carbon footprint as a nation. The final element of the solution, and what we've called the net zero solution, is solar generation and battery storage. So effectively, the maximization of free energy from the roof, the use of that energy for non-time sensitive applications like water heating, for example, and the storage of that energy in battery for the time sensitive applications, whether it be room heating, whether it be when wishing to do your washing and drying at a particular point in time, or cooking your supper through the energy through the battery. Classically, we deploy 4.5 to 5.5 kilowatts of solar on any given roof. That's our target. Our target is to maximize solar deployment. Solar panels are pretty cheap these days, so we can maximize that. Our standard battery configuration is 6.5 kilowatt hour batteries which typically gets the average property through that high cost period of around 4 till 8 p.m. We have many of our more efficient houses. The battery will carry them through the entire day, but the larger houses may require more than one battery, which we support obviously as well. What does this do to energy consumption? And as there's 3 different solutions, you'd expect 3 different behaviors within energy consumption. So just through deployment of the home automation solution, just through the light switch deployment, we've seen around about the 20% energy savings, as in energy savings. The light switches can control traditional combi boilers, so they will. So those savings are achieved through typically switching off the combi boilers when there's nobody in. So if you've gone to work during the day, typically the heating is not on. If you choose to go out for a meal that evening, classically with the classic programmable thermostats, that house will heat up even though you're not planning to get home until 10, 11 o'clock at night. Wonderwall will detect where you are, detect that nobody's come home, and basically avoid that heating that property until you get home. So we can achieve a reasonable level of energy savings just by adding the sensor information and controlling the existing heating system. As we move to the more granular heating systems, such as the hot water tank, as I mentioned, let's heat 30 litres rather than 200 litres every day, and through the infrared panels and underfloor heating, where we can choose individual rooms to heat. We can save quite a significant amount of energy. We did a little analysis on, I think it was a 3-bedroom semi in the Manchester area, which has the Wonderwall system, and looking at how the system performs in terms of heating rooms, how the system performs in terms of occupancy and occupancy detection. And what we've found, and we compared that with the standard SAP model. So the standard SAP model is modelled based on a heating pattern of 77 hours a week, I believe. And the principle is we'll use an hour or 2 in the morning of a weekday and a couple of hours in the evening of a weekday, and then an extended heating cycle over the weekend. But it works out as 77 hours as that standard average model, as SAP describes them as. Through the Wonderwall occupancy detection and how the home is used and the application of heat on an individual room basis, using that model, we create a heating pattern of 38 hours, almost half the amount of space heating required, and that gains effectively 50% energy savings just by heating the rooms that need to be occupied, that are occupied and therefore need the application of heat. And that's through the current stay-at-home pandemic activity. As we hopefully approach back to regular sort of service, let's call it, I'd expect that energy savings to slightly increase again. And ultimately, as we get to the net zero solution, where you're not only controlling and minimizing the amount of energy the home uses, but also starting to generate and store that energy, grid consumption savings, we've seen 90% and beyond energy savings by generating the vast majority of energy through solar generating and storing that. The other really interesting model we found through using the Wonderwall system is how to play more effectively with tariffs and time of use tariffs. So as we've seen in the previous slides and talked about briefly in the previous session, there are a number of tariffs on the market. You know, the most popular tariff for domestic properties today is the flat rate tariff at 15-16 pence per kilowatt hour, regardless of when you use energy. And then we have a number of time of use tariffs, economy 7, economy 10, EV tariffs focused on charging EVs overnight, and then the wholesale tracking tariffs. What we've found with customers who have taken up the wholesale tracking tariffs, where we consume energy at the 3 or 4 pence, typically overnight, and store it throughout the day, what we've found is that combined with solar generation and smart energy export tariffs, and what I mean by smart export guarantee tariffs. So there's to step back a little bit, there's two types of tariffs within the market. There's import tariffs and export tariffs. Everyone has an import tariff. Most people are on 16 pence per kilowatt hour import tariffs, but those import tariffs can also track wholesale markets. So it could be as low as 3 pence a kilowatt hour in the middle of the night, and it could be as high as 35 pence a kilowatt hour in the peak evening period. The export tariffs are associated with pushing excessive solar generation out onto the grid. So you're a generator and delivering energy to the grid. You can be paid through the Smart Export Guarantee Scheme, paid for that export energy. And the best prices for that export energy today is around 4.5 to 5.5 pence per kilowatt hour. So what a number of our properties have done is created the whole, signed up to the wholesale tracking tariff for import and a fixed tariff for export, which basically means on an import basis, they are paying the majority of the time 3 to 4 pence a kilowatt hour for energy consumed, either going into hot water, going into the battery, and they are being paid 5 pence a kilowatt hour for energy exported. From an economic perspective, this solves seasonal storage from a domestic property perspective. Let me explain why. Solar panels generate most energy through the summer. Therefore, the vast excess of energy is being pushed into the grid during the summer months at 5 pence a kilowatt hour. And then during the winter months, there's a shortfall of solar generation, because it's winter. Therefore, that shortfall of energy is made up from taking energy from the grid. But we take energy from the grid at 3 to 4 pence a kilowatt hour. Therefore, from at least an economic perspective, we are selling energy at 5 pence in the summer and buying it back. Obviously not the same energy, but buying energy back at 3 or 4 pence a kilowatt hour in the winter. So from an economic domestic property perspective, that property has seasonal storage through use of the grid. It's not true seasonal storage, obviously, because the energy isn't stored for that period of time, but from an economic perspective, it's seasonal storage. We did a little analysis on one of the first Wonderwall homes deployed at the beginning of spring last year. That property was paying £15 per month as a standard direct debit for their energy consumption. That was then reduced to £10 per month, and they are now £240 in credit. That's the sort of significance of an intelligent digital solution on what can be achieved from a monthly bill perspective. So that's all well and good, great performance, but how much does it cost? So this is a nice simple slide, not that simple, but a slide that describes what Wonderwall costs, capital costs, compared to the traditional gas combi installation, and one Wonderwall costs compared to a traditional heat pump installation. So as you can see, it is more expensive than installation of a gas combi boiler. There are tens of millions of gas combi boilers out there. They've been deployed over many years. That market has got the most economically efficient deployment mechanism that's out there. So about 5.5K to install a combi boiler. Don't forget that includes the boiler, the piping, the connection to site. This is new build properties, by the way, just as an example. And that's also effectively a dying industry. Energy bills for gas combi comes to around about £700 a year, and we hit almost 1.5 tons of carbon through the direct escape of the direct burning of gas within that property. Gas maintenance is annual, and the typical lifespan of a combi boiler is 5 to 10 years. Yes, some last longer, yes, some last shorter. If we jump directly to an example future solution, and by the way, the second half is a cost breakdown of where those prices come from. If we jump directly to the real focus of the decarbonised agenda, which is deployment of heat pumps. Heat pumps, so this is just the heat pump alone, no solar generation, no battery storage, no intelligence, just the installation of a heat pump, is £10,000 or just over £10,000. Typically, energy bills actually go up through the deployment of the heat pump is what we've found. And because they're using standard grid energy, in this particular example, it consumes kilowatt hours from the grid, and therefore there's a carbon cost of grid energy. It's slightly better than the CO2 footprint of a gas combi boiler, but still isn't great. Maintenance annual typical lifespan is around 10 years. Then we compare both of those to Wonderwall. So the capital cost of Wonderwall is typically around 10k. Obviously the size of the house is different, but that's the same applied to the other areas. The annual energy bill is significantly lower because we're avoiding energy consumption at every opportune moment, and we're maximizing the self-generation through solar generation and battery storage. There is no annual gas service check. The typical appliances within the Wonderwall solution last 25 years or beyond. Solar panels, infrared panels. Interestingly enough, the infrared panel mean time before failure is 100,000 hours. Typical usage means that an infrared panel could last 35 years, so some incredibly long life cycles on some of these components. So yeah, so that's a summary cost comparison of how Wonderwall marries up. As a business today, we are deploying quite extensively in social housing. Won a couple of the social SHD, I can't remember the last time, the government competitions around social housing grants, and actually deploying quite significantly in other social houses, new build properties, and retrofit markets at the moment. So the deployment is starting to grow quite significantly. As you can see from an economics perspective, it's very different to traditional solutions. It relies a lot more on digital intelligence and AI, and responding to the behavioural patterns of a home, of the occupants within the home, and the thermal dynamics of the home itself. As a direct result of that, we typically see Wonderwall deployments requiring a lot lower fabric improvements, whereas the low and slow approach of heat pumps require quite significant and invasive fabric improvements for the average retrofit property. Wonderwall, as we are not heating rooms just for that heat to escape through the walls and windows. When it's not in use, then we can get away with quite materially less fabric improvements in many scenarios. But happy to take any comments on that as we move forward. Working with a strong number of housing partners, whether they're new build or retrofit, not a large number of local councils and social landlords in this area, and the estate is growing very quickly as we move forward this year. We have quite high expectations of this year now. Now things are settling down back to business as usual. excuse me. And then finally, multiple award-winning tech awards from property tech through to industry acknowledgements around energy systems catapult and so on and so forth. It's really the key driver to take away from what Wonderwall does. We use digital intelligence to maximize energy efficiency and minimize carbon footprint and minimize carbon and minimize energy costs, rather than using or excessively, in my opinion, using traditional technologies like tens of thousands of pounds on electric mechanical devices and further tens of thousands of pounds on drastically improving the energy efficiency of an individual home, which in many respects is not economically viable for the vast majority of properties in the UK. But still, those probably needs to be addressed from a carbon footprint and energy cost perspective. There's a couple of other features that we specifically developed for the landlord, social landlord estate. Obviously, through the sheer volume of data we collect from an individual property, we can create some really great insights for landlords, understanding how their estate is being used, occupancy levels, humidity levels, indications on fuel poverty, indications on cost management, indications on maintenance requirements for properties, safeguarding vulnerable members of the community through these sensory data as well. And there's a lot more that can be done, and we have plans for, but can't quite share those yet in that area. And we're continuously focused on evolving and improving the platform. The decisions, the AI is applied in the cloud, so the sensory data is uploaded to the cloud in real time, and decisions are made and optimized through that system. So the system, if you deploy a Wonderwall system today, it'll work well. In a year's time, it'll work better. In 2 years' time, it'll work even better again, as the system is constantly learning and improving its behavior. If you switch tariffs, it'll learn based on those new energy costs and take advantage of that different shape and size, all automatically, all without the occupant lifting a finger. So in summary, it's about affordability, it's absolutely about intelligence, it's about simplicity to use. Wonderwall system is actually easier to use than a programmable thermostat because it programs itself. It's fully integrated and scalable and pretty as well. That's it from a presentation perspective. Any questions? Please pop them in the Q&A window and I'll endeavour to answer them.
Sorry, my microphone was muted as usual. Matt, thank you very, very much for the presentation. It was very, very interesting. I have a couple of questions. The first question I would like to ask you is, you presented to us an intelligent gas-free heating system. Yeah. How this system could be compared with the air source heat pumps?
So, no, absolutely. So I mentioned the economics in one of the slides, but let me talk about how air source or any sort of heat pump works compared to the Wonderwall system. So a heat pump is typically single or dual zoned. So it heats water and pumps that water through the home into either underfloor heating systems or oversized radiators. And as we know with gas central heating systems, which uses the same principle, hot water around the home into radiators, control is very coarse control can be done on a zonal basis, upstairs or downstairs, or on a whole house basis. It's either off or it's on. Therefore, you are heating the entire house, or at least upstairs and or downstairs, at any point in time, which is incredibly inefficient when classically and through our sensory data we've discovered in the average home, one room is used 90% of the time, because the family are in the bedroom when they're asleep, they're in individual bedrooms, but when they're together, they're in the living room or they're eating in the kitchen and so on and so forth. That changes for homes with teenagers, surprisingly enough, where they inhabit their room 24 hours a day, 7 days a week, on their Xbox or PC or whatever it might be. But classically, it's 1 or 2, maybe 3 rooms, but it's very low. So why heat an entire house when only a couple of the rooms are occupied? The Wonderwall system is slightly that we use into individual heating panels or heating elements under the floor, and those are controlled from individual light switches. So if a room, if a room is scheduled, is forecast to be occupied through the AI platform, or we detect occupancy within a room that lasts longer than a minute or 2, we heat that room, or we preheat that room ready for that occupancy. I.e., we only switch on that 400-watt panel to warm that room up to a comfortable temperature. The hallway isn't heated, the bedrooms aren't heated, the kitchen isn't heated, the utility room isn't heated, just that room that's being occupied. And as the occupants move through the home, each room is heated. So a massive reduction in consumption just by applying individual energy. A good example is getting up and going to work in the morning. Say your alarm is set for 7:30, the alarm goes off, you get up, your bedroom's going to be warm, because we know movement starts at 7:30 when you swing your legs out of bed and stand up. Maybe you spend 20 minutes in the bathroom from 7:30 to 7:50. The bathroom will be heated for those 20 minutes to keep you warm, comfortable as you jump out of the shower, and so on and so forth. And then straight out the door, straight out the door into your car, or down onto your bicycle, or down to the train station or tram station to get to work. Why heat the entire house for the 5 minutes it takes you to get dressed and the 20 minutes it takes you to roll through the bathroom and wash yourself? That's an enormous energy efficiency saving compared to heating the entire home for 2 hours in that morning.
Thank you very much, Matt. I would like to, you mentioned your presentation that the Wonderwall system perhaps focuses more on newly built homes. Would you like to say a few things to us in relation to homes which are not newly built, especially in relation to the role of the fabric of these older properties? Thank you.
No, absolutely. So hopefully the attendees will track this, because I'll touch briefly on things like U-value and stuff like that. But ultimately, new build homes are typically really quite efficient. They're not perfect, but they have a relatively low U-value compared to the estate we have. Where as we move forward and build more homes, typically that U-value is lower, and therefore they're even more energy efficient. As a side effect of the Wonderwall business, where we started with new build homes and home automation, we've continued that deployment into new build energy efficiency Wonderwall solutions, and especially around the 2025 target I mentioned about not using fossil fuels to heat homes from 2025. So that's been a legacy. So a large part of our estate today are new builds. A smaller but significantly growing part of the estate, the Wonderwall estate, is traditional properties, retrofit properties, as we call them. What we've found, talking to mainly around social landlords, because they are the big driver in retrofitting and decarbonisation of existing properties today, is they've been struggling with traditional solutions. It's possible they've been applying it wrong. It's possible they've not spent enough money on fabric improvements to apply things like heat pumps. But it's been very difficult and challenging, and there has been a number of stories where the work to remove gas and to put low carbon energy sources and heating sources into homes has driven those occupants into fuel poverty. It's absolutely not what we should be doing, and that absolutely needs to be addressed. On the flip side of that, there's been examples. Nottingham, sorry, has a well-published retrofit program that they kicked off a couple of years ago, where they've spent significant amounts of money. I think the quote was £85,000 per property to fully insulate and to fully decarbonise that property. The property were in sorry states to begin with, but it's still a significant amount of money when you're talking possibly 80, 90 or 100% of the asset value to retrofit. That's not economically viable. So what we've been doing as Wonderwall is trying to find a middle ground in a scenario where you don't have to spend many tens of thousands of pounds on external wall insulation or improved energy efficiency, fabric improvements across the entire home, but trying to balance that out with a more efficient heating solution. So through the Wonderwall solution, we have a far more efficient heating solution into the point where we don't heat rooms that aren't occupied. Therefore, less heat is in the property to escape through the walls. Therefore, a lower level of fabric improvements are required and in that typical property. So what we've found through the retrofit deployments we've done to date is properties that typically require external wall insulation, significant improvements to cavities, insulation, double glazing, and roof space, loft insulation, to improve, or basically properties that are very difficult to economically improve. The Wonderwall solution requires a far lower standard of fabric improvements. So typically they do require fabric improvements, typically up to the deployment of internal wall insulation, IWI, very rarely to the point of external wall insulation, but typically it's around improvements in, if it's pre-2000 double glazing, and post-2000 double glazing is required, so those things are popped out. Increase in loft insulation and addressing what is quite often poorly addressed cavity walls, where the cavity has become damp or wet or the fill is patchy. Those sort of standard improvements to achieve similar sort of carbon footprints and bill improvements with a far lower fabric bill, so to speak. Hope that answers the question.
Yes, Matt, thank you very, very much. You answered my question.
I've got a question for you, Matt. So obviously I'm big into my heating. That's where the background I come from. Is it interested to know, have you tried solar thermal integration with your smart hot water tank? And if so, what was the outcomes?
So we've not tried it yet. What we've been focused on to date is the simplest solution possible with digital intelligence. So very simple. There's electric wires running between everything. There's no pipes, there's no water, so there's digital signaling and electric cables, and that's it. It basically means our our space heating solution is extremely simple, therefore extremely reliable and cheap. You know, the individual panels are very cheap compared to alternative approaches. Therefore, from a solar diversion perspective, we simply monitor the amount of solar energy being generated, and if it's enough, we switch the hot water tank on, and it routes through the DC cables to the inverter, and then from the inverter into the hot water tank or into the battery, and if both are full, then we divert it out to the grid and earn a couple of pennies from it. So very, very simple solution. We have looked at solutions around, or integration solutions around, basically either through air or through water systems, piping the heat, the thermal heat generated behind the solar cells into, you know, the pre-charging or hot water or the pre-charge. But again, those systems A, add significant capital cost, and those systems B, add significant opportunities for failure. And having a wet system, as we've probably all found sometime in our lives, you know, radiators can leak, water can escape, messes can be made. Let's avoid that. So our primary, you know, one of our secondary focuses is keep it as simple as possible, keep it as digital as possible, and let's not destroy the carpet through a leaking pipe.
Great, thank you very much. I have got another question for you with regard to the infrared panels that you use. Typically, there is kind of an issue, I guess, with SAP in that SAP is looking at sort of the air temperature a lot of the time, and the far IR panels are heating up things and not the air. Have you found any issues with trying to get this and trying to get your system into houses when people say, well, this isn't working how we think it should work?
The main issue we've had is how blunt a tool SAP is. So I sit on probably 5 or 6 SAP working groups, and if anyone familiar with SAP will know SAP changes very slowly, and you need thousands of conversations in order to make it, to get it to move. But we've got to the point now where 30% of our capability is recognized within, or will shortly be recognized within SAP. But there's 70% of opportunity that the system does today, a Wonderwall system does today, that isn't formally recognized in SAP. Heating hours, for example, I mentioned earlier, 77, you know, regardless of how the property is used, it's 77 hours. But the reality is, you know, properties can be used significantly less, which means your bills are significantly lower, but that's not recognized within SAP. SAP is the lowest possible common denominator. Similarly with smart thermostats that are only just being recognized within SAP. Solar generation is recognized within SAP in a very weird way. So there's lots of work to be done. So we are fully engaged with Building Research, BRE, and we're fully engaged with BASE, we're fully engaged with that. And we are seeing movements in SAP to adopt a more dynamic, more responsive approach to decarbonisation. But there's still some way to go. But effectively, through the Wonderwall system, what we've seen is properties that have had a single bump in terms of E to D or D to C or C to B, bump in terms of the fabric, in terms of the SAP rating of a property for a Wonderwall installation. Every year we see that that bump naturally improving on its own as SAP recognises more of the things we do and more of the digital approaches we take as inherent system. But ultimately, you know, what really shows the difference is your kilowatt hours from the grid per year and the energy bill that lands on your mat or mailbox each quarter. That's what definitively tells how well the system works.
Thank you very much. Any more? I'm going to get my sort of auctioneer's gavel out in a minute and go calling once, calling twice, calling 3 times. Bang. Okay. Thank you very much, Matt, for your time. I think we will be publishing these videos here. You will have Matt's details, I'm sure, if you want to get in contact with him in the future. That's okay. So thank you very much again, Matt, and we will continue to work with you at the University of Salford and Energy House too in the future. Thank you. Right. Now we move over. You did get out, sent out in the email a little bit of homework, and this is all about retrieving energy data from a smart meter using a consumer access device. So you've had an attachment with a sheet of paper. We have asked you to do this as homework, or you can do it in the future, but we will have Yanis now will run through this. So those that you don't know, you have probably seen him asking questions, but Dr. Yanis Paraskivas from the University of Salford is a research fellow working in the area of smart meters and smart homes ecosystem, and is running the Smart Home Smart Meters Laboratory at the University of Salford in Jewel House, the very home previously of James Prescott Jewell. Yanis is working for on both the ERDF projects and commercial projects on smart energy and on domestic energy consumption and production of data analysis. He is also conducting research on the process and analysis of energy and power consumption signals for the pattern recognition application. Yanis holds a Bachelor of Engineering, an MSc and a PhD, all in the wider area of electronic engineering. So without further ado, Yanis, I will pass over to you for you to run through the little exercise that has been set for everybody. Thank you.
Sorry, once more, I was muted. Nigel, thank you very, very much. It was yesterday, wasn't it, that we emailed a few pages on a step-by-step guide on accessing smart metering data. Actually, having the smart meters and the domestic smart metering infrastructure, there is a number of ways that you can access this data. One is directly from the energy suppliers through an API. I'm not sure that all energy suppliers provide this facility. We are using Octopus. We are using the Octopus energy supplier. They do provide this facility, so we can access energy consumption data using the API through Octopus. However, the granularity is 30 minutes. Another way is through portals like the Energy Portal that Matt presented to us in the first talk, and an alternative way is through hardware, through a consumer access device. What happens is the consumer access device, this piece of hardware, is paired with the domestic, our domestic smart meter, electricity and gas, and so all this data is sent to the cloud of, in this case, the consumer access device we used was from Hildebrand to the cloud, and then the consumer, using again API technology, can download their data. So I would like to ask if any of you attempted to access the electricity consumption data using the REST API, the method that we sent to you through the emails yesterday. The idea was to download and use Postman software. I'm not sure how many of you have tried it. I was thinking if we could give you like 10 minutes to try to do it in case you have any questions. Alternative, you could try it during the next few days, and if you have any questions, you could ask Nigel and me on our last session on Thursday. Sorry.
Yeah, please don't be afraid to give this a try. So I'd just like to say, you know, it's only a couple of pages. You don't have to do it now. Like I said, you can do it another time. But I am an absolute digital numbskull. I do not understand anything. But I actually went through the list and managed to do it myself and pull out the data, which absolutely amazed me. Don't be put off by the fact that there's a sort of 3 sheets of paper and lots of figures and things to pull out there. It is, in fact, it's been made exceptionally simple. And like I said, I amazed myself that I could do it myself. Thank you. Back to Yanis. That was just me interjecting there to say how simple it is.
Thank you very much, Nigel. Yes, it is a step-by-step guide actually to see if we have a consumer access device, like an external device, how easy it can be to access our data. Using this device, we can have granularity up to 1 minute using the REST API. However, it is important to mention that the sampling period of each smart meter can go as low as 10 seconds. But all this, we tend to accumulate this data into 1 minute or 30 minutes, depending, because the granularity we need, it depends on what we are trying to achieve, what application we are trying to develop. In this case, using this hardware, it can go down to 1 minute. And when you run, when you follow the steps, you are going to end up with like pairs of values, and one value is the consumption, say in half-hour slots or 1 minute slot, you select the granularity. So you have the kilowatt hours per slot for the granularity you select, and then you have the time stamp. The time stamp is in Unix format, and we have also included in this short guide how to convert from the Unix time stamp to how to say human time stamp, which is quite a straightforward process. If there are no questions, so could perhaps ask you if you would like to give it a go during the next few days and next couple of days, sorry, and then on Thursday when we have our last session, in case you would like to ask us any questions. This actually data is from the lab itself, the smart meter lab, and there you're going to see the consumption is quite low because at the moment most of us are working from home. We have a message from Luis. Luis says that couldn't get it working last night, but all okay now, thanks. Okay, good. Thanks, Luis, for that. And using Postman, Postman can be utilized, as Matt mentioned earlier, in order to access data from the energy platform as well. So Postman is quite a generic software which can be used in order to access data using API, basically. Accessing this data is actually the first step in order to utilize this data for various applications. One application could be data disaggregation, which is quite a hot topic. So from the aggregated signal that we are accessing from the electricity smart meter, we try to identify which devices are used. This is quite important in order to provide the consumer with advice on energy saving. Of course, this data, when combined with information around the occupancy of a household or the life of the individuals when they are working, when they are at home, etc. It can be a very valuable tool, and then we are going to areas like machine learning, pattern recognition, etc. That's all pretty much by me, Nigel.
Thank you. That's today's session finished. So just like to thank Matt again and Yanis for their presentations. We will be back on Thursday at the same time, 12:30 GMT. That's Greater Manchester time, GMT. And the talks then will be from Jose Figueiredo from Critical Software on the home energy management system, and also very interestingly, cyber security aspects of the smart home ecosystem from Felix Ryan. So we are looking forward to seeing you all on Thursday, and thank you very much again to Matt, Yanis, and from behind the scenes, Ben and Alex. Thank you very much.